Proportional and non-proportional relationships. Go ahead and get your notes set up. We got our title and our learning target and I can statement. 7RP2. I can determine whether a relationship is proportional or not. So start with the basics. Here's our vocabulary. Two quantities are proportional if they have a constant ratio or unit rate. So if you remember from last year when we talked about proportions, basically it changes equally. Both parts change the same. So think of if somebody gets taller, their arms and legs should also get longer. Everything kind of grows at the same rate. That we would say stays in proportion. So what that means is that all the quantities have the same unit rate. And that's basically how we're going to compare them all together. Is we take each of the different rates, even each of the different pairs of quantities, and we see, do they have the same unit rate? If they do, they are proportional to each other, meaning both parts are growing at the same rate. If they're not, then we would say that they are non-proportional or not proportional. So here, $88 for 4 tickets. We turn it to a unit rate by dividing both by our denominator, and we would get $22 per ticket. Now, if these two are proportional, we'll get the same thing for both of them. So here we do $110 for 5 tickets. Divide by our denominator to turn into a unit rate. And again, we get $22 for each ticket. So because they have the same unit rate, we would say that these two quantities are proportional. Okay, simple as that. Turn them into unit rates, make sure the unit rates are the same, and we know that they are proportional. So jot this one down. Yes, I want the word problem to go with the data here. It says Andrew earned $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours? So the amount of money to the amount of hours, we just want to know, are they proportional? What that really means is take each pair of data, turn them to a unit rate, and see, do we always get the same unit rate? So it's basically just 4 quick problems. $18 for 1 hour. That's already a unit rate, so we're good there. $36 for 2 hours. So we divide by 2, and I get $18 an hour. So I'm still the same there. $54 for 3 hours. So I divide by 3, and again I get $18 an hour. And then the last one, $72 for 4 hours. Notice on my rate I still have my units. I show my work. I don't just do one of them or 2 of them. I do all of them. In this case, I get $18 per hour. So because they all have the same unit rate, we would say that this is a proportional relationship. Because the amount I earn in comparison to the amount of time spent is the same all the way through. It's at a nice even rate of $18 per hour. So let's try another one. Again, yes, you need to copy down the word problem so that it goes in context with the data in our chart. This one says the Uptown Tickets charges $7 per ticket plus a $3 processing fee per order. We want to know, is the cost of an order proportional to the number of tickets ordered? So here's how it works. $7 per ticket plus an extra $3 for processing. So if I buy 1 ticket, that's $7 for the ticket plus $3, meaning $10 for the cost. If I buy 2 tickets, so 2 times 7 is 14, plus the extra $3 is $17. 3 tickets, so 3 times 7 is 21, plus the $3 processing fee is 24. And 4 times 7 is 28, plus the $3 processing fee is $31. Now, you might already have a feeling about whether this is going to be proportional or not, but you still have to back it up. Show me the work on how you change each one of these to a unit rate. It's good practice. So this one is $10 for 1 ticket, so I'm good. Here it's $17 for 2 tickets. So again, divide everything by your denominator. In this case, I'd get $8.50 per ticket. So we already got different unit rates, so we know it's not going to be proportional. But we want to know, is this the only one that doesn't work, or does any of the other data not match up? So here, $24 for 3 tickets. Well, that would give me $8 a ticket. So it looks like it's getting cheaper and cheaper as I go. And then $31 a ticket for 4 tickets. Sorry, not $31 a ticket, but for 4 tickets. That would divide out to be $7.75 per ticket. So in this case, is this proportional? We would say it's not proportional because we don't have unit rates, or the unit rates are not the same for all the quantities in our problem. So because of that extra $3 fee, that threw everything off, because it wasn't just a nice $7 per ticket. That $3 got thrown in and throws everything off as we buy more and more tickets. So let's try another one. You can use the recipe shown to make fruit punch. We want to know the different sizes or amounts of our mixture. Are they proportional to the amount of mix? So is the amount of sugar proportional to the amount of mix? Again, set it up, find your unit rate. So this is a ½ cup for 1 envelope of mix. It's got a denominator of 1, so we can leave it alone. Here it's 1 to 2, so 1 cup for 2 packets of mix. I got to divide by 2, and I would get 1/2 or 0.5 cups per packet of mix. Here I have 1 1/2. I'm going to go ahead and make that into an improper fraction because I know I need that in my complex fraction here. So 3/2 of a cup over 3 packets of mix. Well, I don't want to divide by 3, so this is one of our complex fractions. So I'm dividing by 3 over 1, so I want to multiply by 1 over 3. 3's cancel out, and I'm left with 1 over 2, or 1/2 of a cup for 1 packet of mix, because my denominator turned into a 1. And then my last one, 2 cups of mix, 2 cups of sugar for 4 packets of mix. Again, divide by my denominator. 2 divided by 4 is 1/2, or 0.5. So I would get ½ a cup per packet of mix. So even though I had some fractions in here, luckily we've been doing our practice with our complex fractions, so we had no problem with it. But I get ½ a cup of sugar for every 1 packet of mix. So because I got the same unit rate all 4 times, I would say that this is a proportional relationship. All right, you're all done. Now, give a little practice and see how you do.